The first step is to formulate this as a matrix problem. The two simultaneous equations are rewritten as a single equation in matrices. The second step is to solve the matrix equation to find x and y. Here we're pre-multiplying both sides by the inverse of the 2 by 2 matrix. Work out what that inverse is. 1 over the determinant times this matrix. If we multiply those two matrices together, we get this, which equals 3 over 2 minus 1. Therefore, x equals 3 over 2 and y equals minus 1. The third step is to check that the answers we found really do solve the two original equations. I'll leave that to you. That's the end of the question, but let's just check we really understand what was going on. In solving this matrix equation, the first line of working we wrote was this one, but I now want to put in a bit of extra detail. What was really happening was that we were pre-multiplying both sides of that equation by this inverse. Pre-multiplying, of course, means multiplying on the left, not the same as multiplying on the right. You have to specify, because matrix multiplication is not commutative. So this is what we were really doing. And then because matrix multiplication is associative, we can choose to multiply these two matrices together first, and any matrix multiplied by its inverse is the identity matrix, so we get this. Right hand side is the same. And then, of course, any matrix multiplied by the identity, well, it's just the same. So those two intermediate lines of working, it would be quite a good idea to put those in, but if you did miss them out in an exam, you wouldn't lose any marks.